the RxJS library provides a central concept called an observable. An observable represents a stream of events over time. Interval is one particular function that returns an observable. So if we run this code, we'll see every 1 second in time, the interval observable emits an action. This diagram is called a marble diagram. You're going to want to get fairly familiar with these. Lots of RxJS documentation uses these as a tool to explain how operators work. We'll touch on a few of the concepts you need to read these in this video. So we can apply any functional transformation to any observable, interval included, by calling .type and passing in the transformation that we want. So for example, we can call map, just like we would have array.map, we can call the map observable operator, and we run this code. We'll see that where before each item emitted contained 0, 1, 2, 3, 4, it now contains the square of each value. So 2 has become 4, 3 has become 9, so on. We also have filter, just like an array. So we can call interval.filter essentially. And let's change the predicate to filter out even numbers. So when I run this code, I typoed, my apologies. So we run this code, we'll see that each value that was even numbered has disappeared, but nothing has shifted temporally, right? So we can still see that here's 0 where 0 would have been, here's where 2 would have been, but 3 and 1 didn't get shifted because it appeared. We've just sort of dropped those from the stream of events. So these observables are infinite, as indicated by this little arrow at the end. So if we increase this time window, which I'm not going to do, to say 100 seconds, it would just keep counting up and up and up. And maybe you want that, maybe you don't. But just to illustrate, we can terminate an observable. And so let's say we only care about the first 3 items out of this observable. So the take, apologies. So the take operator will take only the first 3 items that have been emitted. And then this vertical line behind this marble indicates that the observable has ended. And you can see that the arrow indicating that it continues on past the 5-second window has been grayed out. But the thing that really makes RxJS special is that we have temporal operators. So we can not just shift the stream of events like we would an array, but we can also shift it with respect to time. So for example, there's delay, and let's delay by 2 seconds. And I have to import the operator. When I run it, we'll see that 1 second passes, 2 seconds pass, and then the observable starts, but you may remember it's an interval, so it waits 1 second, and then the first item, then the second item, a second after that, and so on. So let's adjust these time windows a little bit. So let's make the interval really fast, and let's change the delay to 1 second. And we'll see a whole bunch of operations. Sorry, there's a whole bunch of events. But we can also combine operators, right? Just how you could do like array.filter.map. We can take any of the operators we've talked about so far and apply them. So let's also take 3 after we delay. So we'll see that delay of 1 second is still there. And then we take 3 and then the observable ends. We can also filter. And so let's filter to just like we did before, filter to the odd numbers. So you should be able to predict a little bit what this is going to do. So if we run this, you might be a bit surprised by this output, right? Like 0 and 1 disappeared, or sorry, 0 and 2 disappeared. Only 1 came through. We gave a take 3. So what's up with that? Well, the order of operations matters in RxJS. We applied take 3 to the stream before we applied the filter. So there were only 3 items that could possibly be filtered. And so only 1 remains after the filtering. You should be able to predict what this would do if we apply the filter function before we apply the take function. So we can see 3 items did in fact come through, and 0, 2, and 4 didn't count towards our take, because take never saw them. By the time it was passed through the filter operation and into take, those items essentially never existed from the perspective of take. So let's move into a bit more of a practical example, because dealing with streams of abstract numbers is probably not in your day job. So I have a helper function here, which fakes a HTTP request. So like the fetch function that you'd have in a web browser, it just returns a promise that always succeeds. So let's do timer 200. So after 200 milliseconds, it emits an action. And let's say after this timer, I want to run this fake fetch operation. So I can do that by applying the mergeMap operator. And from that, I can do something like this. So what this code does is it says, when we receive 1 item on this original timer observable, I want to run this whole second observable. That observable happens to be calling for the fetch function, but it could be anything we wanted. So we can see that 200 milliseconds pass, and then 300 milliseconds later, that function completes. So half a second in total, right? If we if I comment this out, you'll see previous execution, that's only 200, and with it, see longer. So HTTP requests are pretty hard to get right in an application. So if you did something like this and you say you hooked it up to a button, right? And this represented a button click, a stream of button clicks, and the user is just like pounding on that button, clicking it over and over and over again because they're impatient. We could end up with canceled requests, right? If we've already sent one out and the user clicks the button to refresh again, we might ignore the previous result, even if it's still valid. We might have multiple requests in flight, which would be unnecessary load on our server. We might process the answer multiple times, which would cause poor performance in the user's browser. So getting this right is a bit tricky, and I find that RxJS can really help simplify a lot of that logic. So we're going to comment out this mergeMap operation for a bit, and we're just going to fake a little set of clicks. Apologies, forgot to import interval. Right, so let's say this is hooked up to a button, right? And the user's click, 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 click. If we just hook this straight up to mergeMap, this won't be good because request, 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 request. So we need some operation, some operator or transformation to help us reduce this. So one operator in particular that can help here is debounceTime. And so what debouncing does is it says, and I'm going to comment out the HTTP request for now, just so we can see it on its own. I forgot to import it. What debounceTime in particular does is if you have a dense cluster within, say, 250 milliseconds of the prior event, it will silently suppress that earlier event, and it'll wait until 250 milliseconds, in this case, passes without any other event coming through, and then it'll emit the most recent event at the end of that. So we can see the user was clicking every 200 milliseconds 5 times in a row, but we then said, wait until 250 milliseconds has passed before we do anything, and we can see that 5th item in the stream comes through. So we now know it's safe to hook this up to our HTTP request. And so we see only one HTTP request actually got sent. So great. let's take a look at RxMarbles. So RxMarbles is a website with marble diagrams, just like we saw on RxViz. So let's take a look at debounceTime. So this website, unlike RxViz, where this is just a static image, RxMarbles lets you move the marbles around. And we can see, as we move, say, here's a dense cluster, right? 2, 3, 4, 5, but 3 and 4 have disappeared, and only 5, the last one, gets emitted. And if I move 4 forward, and I can see that 4 becomes the one that gets emitted. So whichever one is most recent is the one that gets emitted. And there's always some delay, right? See if I move this around. So messing with these marble diagrams can be a great way to get some intuition about how operations work. So let's just click through a few of them and see if we can learn anything. Click on merge. So we see there are 2 observables, and then the merge operation is applied, and I see 1 observable comes out. So if I move these around, I can see, okay, well, it seems to be a 1-to-1 flattening of an observable, right? Where it doesn't really matter where things come together, it's just 2 observables flattened into 1, nothing deleted, nothing moved, nothing shifted. Seems simple enough. Let's take a look at, like, skip. Skip 2 is applied to this stream, and I see the first 2 have disappeared. Let's test and see if I'm right about that. I see I moved 3 before, and 2 get removed, and then... Okay. So it seems to be skip 2, whichever 2 show up first, just get deleted. Let's take a look at, say, distinctUntilChanged. So I see, just going based off the name, 2 comes through, and then another 2 comes through, but the repeated 2 doesn't actually come through the output stream. But then it changes again, 1, and it does come through 3, and it does. So I think if, you know, the value that preceded it is the same, then it gets dropped. So I can test that by, I put the 1 before, and then this 2 appears. And if I continue moving it, see the 1 comes after this prior 1, 8 disappears as well. So maybe there's some pretty useful things like that. Useful things to do with that, I mean. So there's 2 different websites that I use for debugging with observables. So RxViz is one of them. The marble diagrams are spectacular in this. It's great for explanations, which is why I've used it here. But RxFiddle is another fantastic website. It has a little bit more features if you're doing stuff with multiple observables or nested observables. So I'd recommend using RxFiddle as well. The RxJS documentation is also fantastic. Getting started, it's going to be your primary resource. This video is not explaining a lot of concepts that you do need to know. So for example, subscriptions and subjects are going to come up constantly in practical use of RxJS, and you're going to need to go learn them. So the documentation is a fantastic resource. And just to point out one particular part of the documentation I think is fantastic. There's the operator decision tree on the side. And so this is like a questionnaire, and it'll point you in the right direction. If you know sort of conceptually what you have to do, but not exactly how to achieve it. RxJS has, I don't know how many, hundreds of operators. So it's likely that you're not going to know what you actually need to do, or actually need to use to achieve what you think you need to. So answering this sort of questionnaire is great for that. So let's say, you know, I have 1 existing observable, and I want to ignore values from the end of the observable. You want the function skip last. Okay. I have some observables to combine together, and I want to subscribe to each in order. You want the function concat, right? I have 1 existing observable, and, right, I mean, you can answer the questions. Just answer the questions, and it'll tell you what function to. So this is really fantastic, and I think this makes like a virtuous cycle when you're learning of, you know, you have some idea in your head of what you want to achieve, go to the operator decision tree, then go to the documentation for that operation, read it. The documentation contains often a marble diagram. Then you can go back to RxMarbles. They don't have every operation, unfortunately, but they have all of the really essential ones. So, if the marble diagram within the documentation is not enough, go play with it on RxMarbles and see if that gives you better intuition. Or, if it's still not on RxMarbles, go build it yourself and play with the inputs on RxFiddle or RxViz. And I think that really makes a virtuous cycle for learning. Yeah. Thanks.